Hi, my dear friends. I welcome to my YouTube channel. Now we are discussing about continuity and differentiability. Uh, Already in previous videos, I discussed some parts of the about this discontinuity and differentiability. Now we want to discuss. We want to continue continuity part. We want to continue of a continuity part. In this continuity, some already previous two videos did. So if you not uh, observe that videos, please you go through that videos and afterwards you see these videos. Until then, if anybody not subscribe my YouTube channel, please subscribe my YouTube channel, like this and share to your friends. Now continue on this topic, continuity and differentiability. So based on class 12, CET, IIT, NCERT, NET, APSET, TSSET and KSET, APSET complete guide of this topic. Part 3 we are discussing. So subscribe my YouTube channel as Tirunagara Manohar. Subscribe my YouTube channel as Tirunagara Manohar. Please. Okay, now come to the topic on continuity. So some important result which we are discussing in the previous videos are about continuity. First one, let f of x and g of x be the two continuous function at x is equal to 0, then f of x plus g of x is continuous at x is equal to a. That means if two functions are continuous separately, then the addition also is continuous at x is equal to a. Next, and its subtraction also continuous at that point, and the product also continuous at a given point. So now its division f of x by g of x also continuous at the given point a, provided g of a which is not equals to 0. Next, and by multiplying constant the any function which is also a continuous function. Already f of x is a continuous function. That continuous function multiplied by a constant, then at a given point, then that is also a continuous, where c is the real numbers. If sixth point, if f of x plus g of x is continuous at a given point a, then we can't conclude that f of x and g of x continuous at x is equal to a. Okay, see here, previously what I told, f of x and g of x be the continuous functions, then you say that addition of that functions f of x plus g of x is continuous. But here in sixth point, see here, observe carefully, f of x plus g of x is continuous at x is equal to a, then we can't conclude that f of x and g of x continuous at x is equal to a. Similarly, conclusion holds for subtraction also, multiplication also, next division also. Okay, then next point, f of x and g of x are continuous, then addition of that functions, subtraction of that functions, multiplication of that functions are continuous except at those point g of x is equal to 0. Except this point, remaining all cases this addition and subtraction, multiplication are continuous. When if f of x and g of x are continuous. Next point, every constant function is continuous. Already we discussed that. Every constant function is continuous. Next, every polynomial function is also continuous. Next, every rational function is also a continuous its domain. This is important. Every rational function is continuous in its domain. Next, all trigonometric and inverse trigonometric and exponential and logarithmic functions are continuous in their respective domains. Next, if f of x is continuous function and f of x is not equals to 0, then 1 by f of x is also a continuous function. Next point, if f of x is continuous, then modulus of f of x is also a continuous. Modulus function also a continuous. Next, by the graph of continuous function is a continuous curve without any break. This is all previous discussed in previous videos discussed. Now, for recapitulation, I kept here all key points. Now comes to the next topic. If you clear that, I will move on to the next topic, that is kinds of discontinuity. Kinds of discontinuity. These are three types mainly. So first one, removal discontinuity. Removal discontinuity means if either f of a is not defined or f of a which is not equal to f of a which is not equals to limit as extends to a f of x. That means f of a which is not equals to either RHL which is not equals to LHL. Left hand limit and right hand limit not equals to, as well as f of a. So then in that case f of x is said to have a removal discontinuity at a given point a, because the discontinuity at x is equal to a can be removed by redefining f of a such that limit as extends to a f of x is equal to f of a. Why this? Because this is a removal discontinuity if either f of a is not defined or f of x is not equals to limit extends to a f of x. So this is about removal discontinuity. If it is clear, I will move on to the next kind, that is second one, discontinuity of first kind. Discontinuity of first kind. See here, if limit as extends to a minus f of x, that means this is a LHL value, left hand limit, and limit as extends to a plus f of x, that means this is a RHL, right hand limit. Both exist. That means if LHL and RHL are both exist but not equal, that means LHL, RHL exist but not equal to RHL. LHL and RHL both are exist but not equals to, then in that case f of x is said to be a discontinuity of first kind at a given point x is equal to a. So this discontinuity of first kind means both left hand limit and right hand limit exist but not equal, then in that case we say that f of x is said to have a discontinuity of first kind at the given point a. Now if it is clear, I will move on to the next type, that is discontinuity of second kind. Discontinuity of second kind. If either limit as extends to a minus f of x, that means either LHL or RHL, limit as extends to a plus f of x, or both do not exist, then f of x is said to have discontinuity of second kind. If any one not exist, then at that point, then we say that f of x is said to have discontinuity of second kind. Already we discussed in previous videos also. Now, if it is clear of these kinds of discontinuity, I will move on to the problems. First problem, see here. First problem, problem 1. This is a IIT question. This is a IIT. In IIT they asked IIT, and for JAM also this is important. NCERT also they asked. So this question, let f of x is equal to 1 when x is a rational number. If f of x value 1 if x is rational, otherwise 0. That means otherwise means if x is not irrational. Sorry, x is irrational. That means not rational. X is not rational or x is irrational. Then in that case, this value how much? 0. F of x value 0. Then we have to show that f of x is discontinuous at everywhere. That means not continuous. So that one we want to show that. For that purpose, solution. Let A be any real number. If A be any real number, then A belongs to Q, rational. A belongs to Q, rational. Then f of A is equal to 1. Q means rational. Then f of A, how much the function according to this definition? This value 1. So that's why f of A, how much? 1. Otherwise, 0. Otherwise, means if A is does not belongs to rational, means irrational, then this value how much? 0 according to the definition. There are infinitely many rationals and irrationals in every interval containing x. We know that. There are infinitely many rationals and irrationals in every intervals a comma b, in every interval a comma b containing x. So that's why when as x tends to a, f of x const tends to a finite number. So that's why in fact f of x oscillates 0 and 1. Okay, so when x tends to a, f of x tends to a fixed number. So that's why because in fact f of x oscillates between 0 and 1, 0 to 1. So that's why limit x tends to a, f of x does not exist, and hence f of x can't be continuous. Can't be continuous. That means discontinuous. Can't be continuous means this is discontinuous at any real number a. That means at every point a. At every point. So this is our first problem. If it is clear, I will move on to the next question. That is second question. This is also IIT based question. IIT CET also they are asking. Next, if CET means Karnataka State entrance exam, if f of x is equal to x divided by 1 plus 1 by x for x is not equals to 0, for x is not equals to 0 and f of 0 is equal to 0. So if f of x is equal to x divided by 1 plus e power 1 by x for all x is not equals to 0 and as well as f of 0 is equal to 0, then we have to show that f of x is continuous function. F of x is continuous function. We want to show that. So see here, for that purpose, first of all, let us show that this f of x is continuous at x is equal to 0. This f of x we want to show that at x is equal to 0. So at x is equal to 0 means if by substituting at x is equal to 0 means f of 0 value is 0 already given. By substituting also we will get it. So next we want to check it, this limit as x tends to a f of x value, we want to check it. What will happen? That means we want to check it, that is x tends to a minus means or LHL. Next x tends to a plus also we want to check. That means RHL also we want to check it. Limit as x tends to a minus means LHL. Limit as x tends to a plus RHL we want to check it. So for that purpose RHL is equal to limit as x tends to 0 plus f of x, which is equal to 0 plus means by substituting this value 0 plus by x value 0, 1 by 1 plus e power 1 by 0. So this value e power 1 by 0 means infinity, e power 0 value infinity. So 0 by 1 plus infinity, 0 by anything 0, 0 by anything 0. This is about RHL. Next LHL, limit as x tends to 0 minus f of x. So by substituting as x tends to 0 in this function, 0 by 1 plus e power 1 by 0. Again, this value 0. So that means right hand limit is equal to left hand limit. So that's why limit as x tends to 0 f of x is exist, that is equal to 0, which is equal to f of 0. So that's why this function f of x is continuous at x is equal to 0. That's all. If it is clear, I will move on to the next problem. That is third problem. Find the points. This is also CET, Karnataka Entrance Exam, CET exam. They asked find the points of discontinuity of the function tan of pi x by x plus 1. Tan of pi x by x plus 1. You have to find the points of discontinuity of this function. Points of discontinuity of this function. So for that purpose, see here, the rational function, this pi x by x plus 1 is not defined at x is equal to minus 1. Why? Because by substituting at x is equal to minus 1, this denominator minus 1 plus 1 becomes minus pi by 0. So that means not defined. So that's at x is equal to minus 1, this function is not defined. So that's why, and hence it is discontinuous at x is equal to minus 1. So that's why at x is equal to minus 1, this function is discontinuous. Next, also tan of kx. Tan of kx is not defined when kx is equal to 2n plus 1 into pi by 2. This value, this tan of kx value is not defined when kx is equal to 2n plus 1 into pi by 2. So that's why, and hence this is also discontinuous at this point. So that's why these both are discontinuous at two cases. That one, first one, pi x by x plus 1, which is equal to this 2n plus 1 into pi by 2, we are making equal. So both side pi get cancelled. Next, by cross multiplying it, 2x is equal to 2n plus 1 into x plus 1. Okay, by cross multiplying it. So I am taking one side these all terms. So that's why 2x is equal to 2n plus 1 into x plus 1. By multiplying, by splitting these two terms, this term as 2n plus 1 into x plus 2n plus 1 into 1. So now this 2n plus 1 into x is there. A plus 2x taken to this side, already minus 2 into x will come, which is equal to 2n plus 1. This is nothing but 2n plus 1 minus 2 is nothing but minus 1 into x, which is equal to 2n plus 1. So this implies x is equal to, what will happen? See here, 1 minus 2x. 1 minus, so okay, x value we want, x is equal to 1 plus 2n by 1 minus, I am taking this term taken to this side, so by taking the here plus is there, which is equal to 0. So then by taking this one, this term taken to this side, this symbol will becomes interchange. So that is 1 minus 2n into x will come. So that's why making x as subject, x is equal to 1 plus 2n by 1 minus 2n. So therefore, the point of discontinuity are x is equal to minus 1. The point of discontinuity are x is equal to minus 1 and x is equal to 1 plus 2n by 1 minus 2n, where n belongs to z. This is the most important for competitive level examination. This problem is most important. Find the what are the points of discontinuity of the function tan of pi x by x plus 1. So what are the discontinuities means? at x is equal to minus 1 and x is equal to 1 plus 2n by 1 minus 2n are the discontinuity of the function tan of pi x by x plus 1. If it is clear, I will move on to the next problem. That is fourth problem. See here, fourth problem. So that the function, this is a NCERT most important question. NCERT most important question, and also as well as competitive level exams also most important. Show that the function defined by g of x is equal to x minus greatest integer closed bracket x is discontinuous at all integral points. Here this closed bracket x denotes the greatest integer less than or equals to x. This greatest integer x denotes the greatest integer less than or equals to x. So what do you want to show? That this function is, you want to show that discontinuous at all integral points. This function we want to show that discontinuous at all integral points. That one we want to show. So that's why let f of x is equal to this first function I am taking f of x as x, and the second function h of x I am taking this greatest integer function I am taking x of x. We all know that this f of x is equal to x is a continuous function. Why? Because linear function this one. So it is a continuous. Then we have seen that h of x is the greatest integer function. We know that greatest integer function is discontinuous. Why? Because this is a stepwise function like this. So that's why this is a discontinuous function. This is a discontinuous function. We know this at every integral points. So take a belongs to z. So g of a is equal to, according to this, g of x is equal to x minus greatest integer x given. So that's why g of a is equal to a minus greatest integer a. So greatest integer a means a. So a minus a is equal to 0. So then we want to check LHL and RHL value. So LHL, limit as x tends to a minus g of x is equal to a minus means g of, limit as x tends to a minus g of x means what? X minus greatest integer x. A minus means we want to take this greatest integer function value as x minus 1 we want to take. So that's why this function value at this case x minus 1 will come. So by substituting as x is to a, so a minus of a minus 1, by splitting this a minus a plus 1 minus a plus a get cancelled, 1 will come. Next RHL value, limit right hand limit as x tends to a plus f of x. That means limit as x tends to f of x means x minus greatest integer x. For this case a plus means x point something will come. X point something, that means 2.135 greatest integer function means 2. So that's why x point something means x will come. This value x minus x as a limit approaching as a. So a minus a which is equal to 0. See here LHL value 1 and RHL value 0. So that's why which is not equals to which is not. So but here LHL and RHL are existed but not equal. So that's why this is the first kind of discontinuity. And hence limit as x tends to a, g of x does not exist. So that's why this is the first kind of discontinuity. G of x is a discontinuity at x is equal to a. See here first kind of discontinuity. See here once again I'll move on to the types of discontinuity. See here, both left hand limit and right hand limit both exist but not equal. So then this is said to be a discontinuity of the first kind. Now, if it is clear, we will move on to the next problem. That is fifth problem. See here, fifth problem. Given f of x is equal to 1 by x minus 1, then find the point of discontinuity of the composite function y is equal to f of x. Composite function given y of f of x. F of x is given. But this function f of x, how is defined? 1 by x minus 1, like this defined. So then we want to show that this composite function has a discontinuity of point of discontinuity we want to find. Point of discontinuity we want to find for this problem. So this is also NCERT part they asked. In NCERT part they asked. This is also very important for competitive level exams also. So that's why we know that f of x is given like this: 1 by x minus 1 is 1 by x minus 1. We all know that this is a rational function. Rational function is discontinuous at x is equal to minus 1. Okay, for x is not equal to 0. At x is equal to 0, this rational function is discontinuous. Why? Because 1 minus 1 0. So that's why this is discontinuous. So for x is not equal to 0, f of x is equal to this f right as it is, this value as 1 by x minus 1. According to this function f of x is equal to 1 by x minus 1 is defined. For this purpose, instead of x, total 1 by x minus 1 is there. So that's why 1 by, instead of x, what is that? 1 by x minus 1 minus 1 is there. So that's why by simplifying this x minus 1 taken into numerator, x minus 1 by 1 minus, see here, 1 divided by 1, by taking LCM, x minus 1 into this 1 minus of 1 into x minus 1. That means this one will move to the numerator as x minus 1 by 1 minus of x minus 1. So by simplifying this, x minus 1 divided by removing these brackets, 1 minus x plus 1. So 1 minus x plus 1. 1 plus 1 means how much? 2. So that's why x by 2 minus 1, 2 minus x is there. At x is equal to 2, this value is discontinuity. So a composite function like this defined x by 2 minus x. At x is equal to 2, this function is discontinuous. So hence the points of discontinuity are already at x is equal to 1 is the discontinuous there. One more discontinuity at x is equal to 2. These are the discontinuity points. So the points of discontinuity are x is equal to 1 and x is equal to 2. So if we clear this, I will end of this session. Next to my dear friends, if you like this my video, please like this video and share to your friends and comment on my comment box. Thank you one and all, thank you very much. And subscribe my YouTube channel as Tirunagaram Manohar. Subscribe my YouTube channel as Tirunagaram Manohar. Thank you one and all, thank you very much.